Hello, welcome to this lecture series on Iupac Nomenclature. In this lecture series, I am going to discuss how to name an organic compound using the rules given by Iupac system. Okay, let's get started. Iupac name of an organic compound contains actually 5 parts. What I'm going to do in this first lecture is that we'll discuss about how to write the Iupac name for aliphatic compounds. First, let us start with aliphatic compounds. Then we'll discuss about aromatic compounds. Right? Okay, so Iupac name of an organic compound or specifically aliphatic compound contains these 5 parts. Okay, that is it contains a root word or a word root. It contains a root word. Okay, then it contains 2 prefixes and 2 suffix. Okay, that is a primary prefix, and secondary prefix. Similarly, primary suffix and secondary suffix. A Iupac name of an organic compound, okay, generally contains these 5 parts. It is not necessary that all the 5 parts should present. Okay, for some organic compound, some of the part may be absent also. Okay, yeah. So usually or in general, the Iupac name of an organic compound contains these 5 parts. Right? Yeah. Now I will give the meaning for each of these parts. Okay, the root word gives information about the number of carbon atoms in the parent chain. Okay, you know very well, if an organic compound is given, okay, what we have to do, we have to fix the parent chain in the organic compound. What is a parent chain? Parent chain is the longest carbon chain that is possible, okay, for the given compound. Right? So root word tells you about parent chain or number of carbon atoms in the parent chain. Suppose if we have 1 carbon in the parent chain, we use the root word as meth. If the compound contains 2 carbon, we use the root word as eth. 3 carbon means prop. 4 carbon bute. Okay, I'll read it as bute. 5 carbon pent. 6 carbon hex. 7 carbon hept. 8 carbon oct. 9 carbon non. 10 carbon dec. Okay, so these are all the root words that we use. I repeat once again, root word gives information about the parent chain. Okay, what is parent chain? Parent chain is the longest carbon chain that is possible in the given organic compound. Okay, yeah, and whenever functional group, yeah, we are going to discuss that. Functional group will come in secondary suffix. Whenever functional group contain carbon atom, that carbon should also be included in the parent chain. Okay, if functional group contain carbon, that carbon should also be included in the parent chain. Okay, this is another important point you should keep in mind. Right, then what about this primary prefix? Primary prefix gives information about the presence of cyclic structure in the molecule. Okay, so what's the meaning? See, the compound may contain alicyclic ring, or it may contain bicyclic compound, it may be a bicyclic compound, it may be a spiro compound. So depending upon what cyclic group that is present, okay, that information should be mentioned in primary prefix. Okay, so if it is an alicyclic compound, aliphatic cyclic compound, then we use the word cyclo. Okay, it may be cyclopentane, cycloheptane, whatever it is. If it is an alicyclic chain, we should mention a cyclo word in front. Okay, if it contain if it is a bicyclic compound, we use the word bicyclo. Bicyclo. If it is a spiro compound, we use the term spiro. What is meant by cyclo, bicyclo, spiro? Yes, we'll discuss all these things as we go along in this lecture series. Okay, then what about the secondary prefix? Secondary prefix gives information about the substituents. Okay, you know very well, when we fix the longest carbon chain, okay, the groups which are not part of the chain, are usually considered as substituents. The substituents should be named in the secondary prefix. Okay, let me give some of the groups which comes in secondary prefix. Nitro, okay, we call it as nitro, okay, NO2 group, nitro. Then halo groups. Then alkoxy group, OR means alkoxy, depending upon the alkyl group. If R is methyl, we call it as methoxy. If R is ethyl, ethoxy. Okay, nitro, halo, alkoxy. Then alkyl groups. These four always comes in secondary prefix. I repeat, these four groups always should be named in secondary prefix. Right. Then suppose if a compound contain two or more different functional groups. I repeat, if the compound contain two or more different functional groups, what we'll do, we'll fix one functional group as the functional group. Remaining functional groups should be treated as a substituent. Okay, so the functional groups which are treated as substituent, that also should be mentioned, okay, in secondary prefix. Okay, for example, if you have a hydroxy group, okay, if it is treated as a substituent, then it should be mentioned, right, in secondary prefix. Hydroxy group, it is actually called as hydroxy in secondary prefix. Whereas same OH group, if it comes in secondary suffix, we call it as all. Okay, methanol, ethanol, like that. That is functional group name. If the functional group is treated as a substituent, then we use this term, hydroxy. Similarly, CN group is called cyano. Aldehyde group, CH2O, it is called as formyl. Okay, like this many terms are there. Okay, for each and every functional group we have the secondary prefix name. Okay, yeah, we'll discuss all those things as we go along in this lecture series. Right, then primary suffix. What information we get from the primary suffix? Primary suffix tells you about whether the parent chain is saturated chain or unsaturated chain. If the parent chain is saturated means all the bonds between the carbon atoms in the parent chain should be single bond. If all the bonds between carbon atoms in the parent chain are single bonds, we use the suffix as -ane. Primary suffix as -ane. Suppose if there is any double bond present, then we use the suffix -ene. Okay, for single bond we use the suffix -ane. For double bond we use the suffix -ene. For triple bond we use the suffix -ine. So the primary suffix indicates, okay, whether the parent chain is saturated or unsaturated. Unsaturated means whether it contains double bond or triple bond. Okay, those information should be mentioned here. Then secondary suffix. Secondary suffix tells you about the nature of the functional group present. It gives information about functional group. What is functional group? Functional group is a group which is responsible for the chemical property of the compound. Okay, it may be alcoholic group, it may be an aldehyde group, it may be a carboxylic acid group, right? Whatever it is. Functional group, okay, is nothing but the group responsible for the chemical property of the compound. Right. Now, for each and every functional group, we use a suffix name. Right. For example, if the functional group is OH, then we use the suffix name as OL, all. If the functional group, suppose if we take aldehyde group, CHO, we use the suffix as AL. If it is a ketone, if the functional group is a ketone, then we use the suffix ONE, own. Okay. If it is a carboxylic acid group, COOH, we use the suffix as oic acid, oic acid. Okay. If it is a cyano group, CN, we use the suffix name as nitrile, nitrile. If it is an ester, COO, if you have ester functional group, we use the suffix name as OAT, O-A-T-E, O8, methanoate, ethanoate, like that. Okay, like this we have other functional groups. Okay, we will discuss all those things as we go along in this lecture series. Okay, then so the IUPAC name of a compound in general contains these 5 parts. Okay, root word, primary prefix, secondary prefix, primary suffix, secondary suffix. Okay, and these are all the informations we get from the name of the organic compound. Okay, then this is another important point. Whenever the secondary suffix, okay, name, the first letter, okay, see the first letter of the name, if the first letter is a vowel, then you should remove this suffix E. Okay, in the primary suffix, you should remove this E. I repeat, whenever the functional group, the first letter of the functional groups, if it is a vowel, then you should remove the E letter from the suffix, from the primary suffix. Okay, if it is not a vowel, say for example in the case of nitrile, okay, first letter is N, it is not a vowel. In this case, you should retain that E. You should retain that E. Okay, now this is another important point you should keep in mind. Right? Yeah. Now, another information I like to give here. Suppose if the molecule contain, or if the given organic compound contain 2 or more different functional groups, okay, then you have to fix one functional group as a functional group, and you should treat the remaining functional groups as substituent. On what basis we have to fix, okay, one particular functional group as a functional group? How to do that? For this, IUPAC has given a priority order for the functional groups. So I am going to introduce the priority order now, and based on the priority order we have to decide, okay, what is the functional group for the compound and what are the functional groups should be treated as substituent. Okay, yeah. So priority order, or the preference, we can say in the other way. Okay, priority order. Right? In priority order, I am going to give you the priority order for some common functional groups. Okay, we also have some uncommon functional groups, okay, in organic compounds. I am not going to discuss that. I am going to give you only the common functional groups. Right? So carboxylic acid as the highest priority. Right? Then sulfonic acid, SO3H. Okay, then anhydride, acid anhydride, then esters, then acid halides. Okay, it may be acid chloride or acid bromide, whatever it is, acid halide. Then the series actually continues. Then amides, CO NH2 amides. Then nitriles, CN. Then aldehyde, C double bond OH aldehyde. Then keto compound. Then alcohol. Then thiol, SH. This order goes again. Okay, I don't have space there, so I'll continue here. Then amino groups, amines. Then carbon-carbon double bond. Then carbon-carbon triple bond. Okay, then we have halo group, okay, nitro group, everything comes, okay, after that. And I have told you halo, nitro, all these groups are always treated as a substituent, and those groups should be named halo, nitro, all these groups should be named, okay, in the secondary prefix. Okay, so this is the priority order. Keep this in mind. Okay, there is no trick available here, but what I will say is that whenever functional group contain carbon, okay, those functional groups should come, they get some higher priority, okay, in general, right? Then you just write this 1 or 2 times, so automatically you will remember all these things. Okay, it is not a big thing. Now this is the priority order, right? Then while naming organic compounds, okay, suppose if you have 2 or more substituents, 2 or more different substituents, what you have to do, you have to arrange the substituents in the alphabetical order, and you have to write, okay, in an alphabetical order. Okay, this is the rule given by IUPAC. Okay, so we'll discuss that. We'll discuss all these things as we go along. Now let me take few examples, and I'll show you how to name the organic compound using IUPAC rules. Okay, yeah, let us start with the number 1. Okay, I'll take some simple examples first. Okay, then as we go along, we'll discuss some complex examples or the questions that appeared in previous year NEET examination, JEE examination, and NCRT examinations and all. Okay, we'll discuss. It's a CBSE examination. Okay, right, so let me take a simple compound first. CH3, CH2, CHOH, CH3. This compound, okay, it contains 4 carbon atoms. Now how to name this compound? What I'm going to do first, we must fix the parent chain. I have told you already, parent chain is the longest carbon chain possible in the given organic compound. Okay, suppose if functional group is attached to the parent chain, that is better. Okay, so you have to select that chain. Now see, OH group is attached here. Now I am going to select the longest carbon chain possible here. This is the longest carbon chain possible. Okay, after fixing the longest chain, we should give number. Listen, numbering should be you should carry out numbering only if it is required. For some simple compounds, numbering may not be required. Okay, so keep that in mind. What is the purpose of numbering? Numbering should differentiate, okay, isomers. If you have 2 or more different isomers, then you need to distinguish the isomers. Okay, for that purpose we use the numbering systems. Okay, right, so keep this in mind. Usually we should follow numbering system. Number should be given, but for some simple compounds, okay, numbering may not be required. Okay, yeah, so here we are supposed to use numbering because depending upon the position of OH group, okay, you will get different isomers, right? Yeah, now always while giving number, you should start from the terminal carbon. So in the parent chain, this is one terminal carbon, this is another terminal carbon. You should start the numbering from terminal carbon. You can start from this side or you can start from this side. If I start from this side, I'll get this is 1, 2, and this carbon gets number 3. So functional group attached to carbon gets number 3. Okay, if I start numbering from this direction. Suppose if I start numbering from this direction, this is carbon number 1, this is carbon number 2. Okay, according to IUPAC rules, okay, the functional group attached to carbon should get least possible number. Okay, so in that sense, okay, if I number from in this direction, I'll get number 2 for this carbon. Right? So what's the name of this compound? Name of this compound is now OH group is treated as functional group. Therefore, name of this compound is, there is no secondary prefix here. Okay, there is no other substituents, and there is no cyclic rings are there. So there is no secondary prefix, there is no primary prefix. So we should go directly to the word root or the root word. Root word. So we have totally 4 carbon. So root word is but. And between the carbon we have only single bond, therefore ane, butane. OH group is a functional group here. For OH group, the suffix name, secondary suffix name is ol, ol. See the first letter is a vowel, therefore we should remove this suffix e. Okay, and what's the name? Name is this, butane, butan. Okay, in the second carbon we have the OH group, butan 2-ol, butan 2-ol. Okay, this is the IUPAC name for this compound, butan 2-ol. Right? Yeah, it's very simple, but you require some practice. Right? Now let me take another compound, compound number 2. I'll take simple compounds, CH3, CH, Cl, CH2, CHO. Okay, this is an halogen substituted compound. So I have an halogen atom here and we have an aldehyde group here. Okay, so if you compare the priority, I told you halogens, nitro groups, they have least priority. So definitely aldehyde has the highest priority in this case. Therefore aldehyde should be treated as the functional group and halogen should be treated as substituent. Okay, and I have also told you, whenever functional group contain carbon, that carbon should also be included in the parent chain. So the parent chain should include this aldehyde carbon also. Okay, now how to name the compound. And one more information, whenever functional group contain carbon, that carbon should be given the least possible number, right? Or that carbon should get the least number. In this case it should get number 1, because aldehyde group always present at the terminal position, right? So I'll give number 1 here, 1, 2, 3, 4. So the halogen atom is present at attached at carbon number 3. So what's the name? While naming, halogen should be named first, because halo group, nitro group, alkoxy group, all these groups will come in the secondary prefix. They should be named first. Okay, so halogen is attached to carbon number 3. So name of this compound is 3-chloro, right? Then there is no cyclic ring, so no primary prefix. So what's the word root? The word root is, we have totally 4 carbon, so but. Between carbon atom we don't have any double bond or triple bond, so it is ane, ane. Okay, 3-chlorobutane. Then aldehyde group, the suffix name is al. See the first letter is a vowel, therefore you should remove this e. So what's the name? I'll rewrite the name here, 3-chlorobutanol. You need not mention the position of aldehyde group, because aldehyde carbon always get number 1. So you need not mention the position of the aldehyde group. So what's the name? 3-chlorobutanol. Right? This is the IUPAC name for this compound. Right? Yeah. Let me give another. We'll discuss few more examples. IUPAC nomenclature definitely requires some practice. Okay, so let me give the name. In this lecture, I'll discuss simple examples. As we go along, we'll see some complex examples also. Right, now let me take a compound CH3, CH2, CH, CH3, O, CH2, CH3. I'll take a compound like this. Okay, say oxygen atom is sandwiched between two alkyl groups, so it's an ether. Okay, you know very well ether as the general formula, right? Like this, that is oxygen atom is sandwiched between two alkyl groups or two aryl groups. So this R group may be alkyl, R group may be aryl, or one alkyl, one aryl, it may be of any kind. Now, how to name an ether? Okay, what we have to do, see the alkyl groups attached. The one which contain lesser number of carbon, that group should be taken along with the oxygen. See here we have 2 carbon, this side we have 4 carbon, so this is a simple alkyl. That simple alkyl should be taken along with oxygen. We call this group as ethoxy group. Ethyl group, oxygen, so it is called ethoxy. Okay, and that should be treated as substituent. Okay, ether, you know very well, always ethers, right, alkoxy groups always comes in secondary prefix. Okay, so it should be named first. It should be named first. And now I am going to fix the longest carbon chain possible in this compound, or the parent chain. The parent chain is this. Always we should treat alkoxy group as substituent. Keep that in mind. Okay, now you select the parent chain. So this is the parent chain, and I have also already told you, while giving number, you should start from the terminal carbon. You should start from here or from here. If I start numbering from this side, I'll get number 3 for this carbon. So substituent is attached to number 3. Whereas if I start from this side, I'll get number 2 for this carbon. I have told you, according to IUPAC rule, the substituents attached to carbon should also get least possible number. Okay, so I'm going to give numbering from this direction. 1, 2, this is 3, and this is 4. So this ethoxy group is attached, okay, at position number 2. So what is the IUPAC name? IUPAC name of this compound is 2-ethoxy. 2-ethoxy, and we don't have any cyclic ring, so we have a long chain of carbon which contain 4 carbon atoms. So root word is but. Between carbon we have only single bonds, so the primary suffix is ane. Okay, so name of this compound is 2-ethoxybutane. That's all. Very simple. Right? Let me take another example. We'll consider a compound like this. Okay, now see, we have methoxy group, halo group, and keto group. Right, according to priority order, keto group has the highest priority. Therefore, keto group, okay, should get least possible number. That's the idea. And whenever functional group contain carbon, that carbon should be included in the parent chain. Okay, so name of this compound is this. That carbon should also be included in the parent chain. This is the longest carbon chain possible in this compound. Right? So if I give the number, okay, here I'll give, if I start numbering from this direction, okay, number 1, 2, 3, 4, 5, 6. Right? In the 4th carbon I have halo substituent, in the 5th carbon I have methoxy. So 4th carbon I have halogen, 5th carbon I have methoxy, so 4 plus 5 I'll get 9. It is called sum of locant position. Okay, I have a locant at 4, I have another locant at 5. Okay, I have a substituent at this location, I have a substituent at this location, and add the two locants. Sum of locants, I am getting number 9. If I start numbering from in the other direction, okay, if we start numbering from this direction, 1, 2, 3, 4, 5, 6. Okay, here the keto carbon gets number 4, and you know very well keto is the functional group in this case. So functional group should get least possible number. That's the idea. So if I give number from this direction, I'll get number 4. Whereas if I give number in this direction, I'll get number 3. So the correct way of numbering is from left to right. Okay. So what's the name of the compound? Name of this compound is, in the 4th carbon we have halo, chloro. In the 5th carbon we have methoxy. So first letter of chloro is C. First letter of methoxy is M. Okay, you have to arrange it in alphabetical order. So alphabetically, C should come first. Therefore, name of this compound is 4-chloro, then 5-methoxy, a small letter. First letter should be capital. Okay, all remaining letters should be small. 4-chloro, 5-methoxy. Then the parent chain contains 6 carbon, so root word is X. And in parent chain, between carbon we have only single bonds, therefore ane. 4-chloro, 5-methoxy, hexane. Okay, and functional group is ketone, so the suffix should be -one. Okay, first letter is vowel, so you should remove the suffix E. Okay, what's the name? The name is this. Let me write again. 4-chloro, 5-methoxy, 5-methoxy, hexane. That ketone is present at carbon number 3, so 3-one. 4-chloro, 5-methoxy, hexane, 2-one. This is the IUPAC name for this compound. Okay, keep this in mind. IUPAC name is a single word. In few cases, like carboxylic acid, and okay, in few cases the acid word will write with a small gap, but in general IUPAC name, keep this in mind, IUPAC name is a single word. Right? Now let me take one more example, then I stop. I'll take one more example. 5. CH3, C double bond O, CH2, CH2, Cn. Now I have two functional groups. One is keto, the other one is cyano. If you see the priority order, in priority order compared to keto, cyano has highest preference. Cyano should be given high first preference. Okay, so priority is high for cyano group. Therefore, cyano group should be treated as functional group, and the keto group should be treated as a substituent. Now, what we have to do in this case is, listen. First, you should fix the longest carbon chain. Since the functional group contains carbon, the longest carbon chain should contain that carbon also. This carbon should also be included. So the longest carbon chain is this. Okay, this oxygen, right, become a substituent now. You should not call it as keto, okay, anymore. It is just an oxygen atom, right? And we should start the numbering from the cyano-carbon, because cyano group is the functional group. Whenever functional group contain carbon, that carbon should get least possible number. So let me start the numbering from here. 1, 2, 3, 4, 5. Okay, what's the name of this compound? Very simple. In the 4th carbon we have an oxygen atom, so it is called 4-oxo. See the name, 4-oxo. Oxygen should be named as oxo. 4-oxo. There is no cyclic ring, so you can directly go to the root word. root word is there are 5 carbon atoms, so root word is pent, and between carbon we have only single bond, so ane, 4-oxopentane. Functional group is nitrile group. It is called nitrile. Nitrile. First letter is not a vowel. Therefore, this E should be retained. Okay, so what's the name? Name of this compound is, I'll write here, 4-oxo. This is the correct name. 4-oxopentane. 4-oxopentane nitrile. Nitrile. Okay, this is the name of this compound. 4-oxopentane nitrile. This is the name of this IUPAC name of this compound. Okay, so this is how we should name organic compounds using IUPAC system. Right? I stop here. We'll discuss with more examples. Okay, in the next in the forthcoming lectures. Okay, yeah. Thank you for listening.